So hello and welcome everyone. So today we're going to discuss about the famous inorganic and the very important topic from the inorganic chemistry, that is symmetry and the point groups. So as your exams are there, so I just hope that all of you are good and you're doing well. So basically what symmetry is nothing but the object which is going to be a symmetric via some entities are there. Let's say the first important thing is the symmetry element. Now what are the symmetry elements? The symmetry elements in terms are first of all they are point. The second one, which is called as a line, or you can call it as an axis. We can go the third one, that is called as a plane. Now these are the important three types of symmetric elements. These are called as a geometrical entities. By using that we can do the manipulation onto the molecule. So based on its symmetry element, we can generate the symmetry operation. What are the symmetry operation? Symmetry operation. Now, the basic difference between the elements and what operations are. Operations will be how to do on a molecule. So let's begin with that example. So a point generates the inversion, a line or axis which will generate the rotation, the plane which generate the reflection, every object in the inverse they have its own identity. So basically what identity? And the last one, that is a combination of rotation and the reflection, that is called as a improper axis of a rotation, that is called as a SN. So these are the very fundamental things which must going to be learned whenever we deal with the symmetry and the point group. So let's discuss one example of a water molecule. Now let's work on to the water molecule. Let's say this is water. Now here, if you looked onto this system of the water molecule, this water molecule is now when I'm going to just pass an axis through the oxygen molecule or through the oxygen as a center, I am going to do the rotation of the molecule. Now this is called as an axis, or we can call as a line, which is example of symmetry element. And from that symmetry element, I will going to do the manipulation. That is, a manipulation means geometrical manipulation onto the molecule, so you will get the equivalent structure. So if I rotate that particular molecule, what happened? I will get this. Now, if you compare between the first molecule and the second molecule, they are said to be the equivalent one. And that phenomenon is called as a rotation. That is called as a rotation, which is denoted by the Cn. What is that Cn? The C is a. What is that Cn now? C is a symbol for the rotation process. What is N is an order of rotation. Order of rotation. Now that N is obtained from the formula, that is theta is equal to 360 by n, or n is equal to 360 by 3. Let's begin with this example again. What is the molecule which is on treatment with the rotation, particularly the process of the rotation, and we will get this. Now that is now the required angle for this, and again I will do the one more rotation to this molecule. I am back to the original. What is the original one? This is what H1, this is what H2. Now there are two rotations are done onto this molecule to get the original one. Now these are the structure. This is first, this is what the second, and this is what the third. So first and second are equivalent. Second and third are also equivalent, but the first and third are identical. And from that we can predict the formula, that is this, right? That is n is equal to 360 by or sorry, the theta is equal to 360 by 2. So that means it becomes a 180. That means the 2 is the order of rotation. So here the C2 is the axis which is going to be used here for the rotation purpose. That means C2 is said to be the principal axis. Is said to be the what? Principal axis. Now using that axis, I am going to, and I am done the rotation operation. So symmetry element is an axis or a line on which I am going to, using that symmetry element, I will do the rotation. So rotation is a manipulation, that is called the geometrical manipulation. Okay. So in this way you can find the symmetry element in the molecule. Okay. Now let's work more on this molecule. I am talking about the reflection. Now reflection means by passing the imaginary plane, that is a sigma. By passing what? The imaginary plane onto this molecule, that molecule should cut into the equal half. That is going to be called as a the reflection, right? So let's say the water molecule is here. This is what H2, this is what H2. If I am just putting this molecule in front of the mirror, what happens? You will get this. This is what H2, this is what H2. This is called the reflection process. Now how many different types of the planes are possible in this water molecule? Now the first is by passing the plane or imaginary plane through this. Okay. Now look at this plane. That plane is going to pass through the center. It is same that as that of your principal axis, and it cut into the two equal half. So this will be called as a vertical plane of symmetry. What is that? V? V indicates it is a vertical plane which is used in the reflection. Now the second one, which is also be possible here, look at this H1 and H2, and I am going to pass the plane through this. Now look at this. Now what type of plane is this? The plane which is passing through all the atoms of the molecule. Again it is parallel with the perpendicular axis. Parallel with the principal axis. Which is the principal axis? This is what your principal axis C. Here also the principal axis is there. This is also what C2. Okay, that means there are two different types of vertical planes in a molecule. One is said to be the sigma V1, second is said to be the sigma V, or sigma V and sigma V dash. So on a very simple molecule, that is the water molecule, with the help of these two symmetry element, example is axis and the plane. These are the two geometrical entities or symmetry elements. Using that elements, I am going to do the manipulation. That is called the operation. Okay. So axis generate the rotation, plane generate the reflection. Right? This one. One more, and every object always have its own character, that is called as an identity. So here, how many symmetry elements are possible for the water molecule? Now, this water molecule is looking like this one. Okay, this is what the water molecule, which is belong to the sp3 hybridization. The geometry will be tetrahedral, but it is a V shape because of what? The lone pairs are present. The structure is going to call as a distorted. It's not a regular structure, and here the angle is near about 180 degree. Okay, now how many bond pairs are there? So in this molecule, total number of bond pairs are 2, and the lone pairs are 2. Got it? Okay. Now this is what the information which is collected from the VSEPR, that is VSEPR. Now that's the theory is given by Nylom and Gillespie. Now next to that, in water molecule, how many symmetry elements are there? One is called the C2, second is called as the sigma. Okay, C2 means it is a, that is a order of rotation will be 2 and the angle will be 180, and here sigma as our vertical sigma. Okay, here angle will be 180 and vertical plane is there, and every molecule have its own identity. Now how many symmetry elements are there? 3. Okay, out of that, this is C2, one is identity, and here this is sigma P1 and sigma B and sigma B dash. This both belong to reflection family. Now if we collect, this is called as the symmetry elements. This is called as a symmetry elements. Now from which that symmetry elements I am going to convert into Schoenfly symbol, that is called as a point group. Now what is that point group now? The point group is basically the collection of all the symmetry elements. Okay, that is simply called as a point group. Here the C2 is the principal axis which is present in water molecule, and the vertical plane, which is what the vertical plane due to the reflection. So if you combine these two now, because identity is present in every molecule, whatever molecule you have, in that particular molecule, so the identity is there. So C2 combination with sigma B, so the point group for the water molecule is C2B. So C2B is the Schoenfly symbol, or one can say the point group for that particular molecule, which have all the symmetry elements, or which is a combination of what symmetry elements. Let's work on to some more molecule. Let's say example ammonia. So first you collect some information about that ammonia. It is a hydrates of nitrogen. Similarly, hydrates of nitrogen. Similar to that of, must mention the structure. Okay, if possible, make the structure. How many bond pairs are there? Hybridization will be sp3 tetrahedral, and the shape will be what? The pyramidal. Right? Next part is what? The bond pair. So bond pair is equal to 3, and here lone pair is must be 5. The angle will be 107, as you know. Now in this ammonia, we have to must find out. Okay, this is the structure, tetrahedral structure of ammonia, and I am going to use the C3 axis. Here, this is what the axis which is passing through the nitrogen. Okay, and you can also give the number 1, 2, and 3. So this is what the axis which is I am going to call as a C3. Why? Because it is C3 now. You will take 3 different rotations now, right? After the 3 rotation, you will get the identical structure. That's why it is a C3. I am not going to in detail. Okay. Now, how many vertical planes are? Again, identity is there. Every molecule have its own identity. Identity means what? Nothing to do now. That's called identity. Now, one more. How many NH bonds are there? There are 3 NH bonds are there. That means there are 3 vertical planes are possible. What type of the plane is there now? Look at this structure. How I am going to pass the plane. Okay? Here, this is what H1, H2 and H3. Now, I am going to make a plane like this. this is what the plane. Okay, so the plane again which is passing or which is parallel with the principal axis, that is Cn. Okay, this is what the Cn, which is called as a principal axis, and I am going to pass a plane through the nitrogen hydrogen bond. Then how many nitrogen hydrogen bonds are there? 3. So the possibilities are 3 sigma V's are there. So one is a C3, identity, and sigma V. These are the symmetry elements from the ammonia or for the ammonia. And if we want to make a point group, then it will be a C3b. Then one more question is there. Then how many C3 are there? Okay. Then for that we have to do the rotation of the molecule. Now let's begin with this example. I am going to rotate that molecule. Ammonia molecule is going to rotate it now. Okay. What happened now? So H1 will take the position of H3. H3 will be here. H2 will be here. We will get the equivalent. We will perform one more operation. What happened? H3 will be here now, right? And lastly again you perform the same operation. So H3 will be back to original position. Then how many C3 are possible now? C3 1, C3 2, and C3 3. So that means C3 1, C3 2, and C3 3. So this C3 3 is an original, that is identical. That's why how many C3 are possible? 2 C3 are possible. Why C3? Because it took 3 rotation operation. Okay, that means the angle of rotation for particularly the ammonia molecule will be theta is equal to 360 by 3. So it must be a 120. And here the Cn is equal to 3. Okay, N is equal to 3. So basically from that, how many symmetry elements present in the molecule are? One is a 2C3, one is identity, and how many sigma V's are there? It depends upon number of NH bonds. 3 NH bonds are there, so 3 sigma V's are possible. Yes. So total symmetry elements for ammonia molecules are 3 plus 2 plus 1, that is 6. And the point group for ammonia molecule is this one. So this is very simple about that, the symmetry and particularly for the point group. So in our syllabus, what C3V and C2Vs are there. So how to predict from that molecule. So you just go through it, you will get the details. Okay, thank you.